This sequential device loads the data present on its inputs, and then moves or shifts it to its output once every clock cycle, hence the name shift register. Data bits may be fed in or out of a shift register serially, that is one after the other, from either the left or the right direction, or all together at the same time in a parallel configuration. Let's perform serial in, parallel out. Connections are made, as per circuit diagram. Set mode to low, that is logic 0. Apply the data at serial input, and apply 1 clock pulse, at clock R, right shift, and observe this data at QA. Now, apply the next data at serial input, and apply 1 clock pulse at clock R, and observe that the data on QA will shift to QB, and the new data applied will appear at QA. Repeat these steps for loading and shifting data. Let's perform serial in, serial out. Set mode to low, that is logic 0. Load the shift register with 4 bits of data, one by one serially. Data loaded is 0, 0, 0, 1. At the end of 4th clock pulse, the first data, D0, appears at QD. Apply another clock pulse, the second data, D1, appears at QD. Apply another clock pulse, the third data, appears at QD. Application of next clock pulse will enable the fourth data, D3, to appear at QD. Thus, the data applied serially at the input comes out serially at QD. Let's perform serial in, parallel out, left shift. Set mode to high, that is logic 1. Connections are made, as per circuit diagram. Connect the clock pulse to clock L. Connect QB to A, QC to B, QD to C and D to logic input. Apply the data at D input, and apply 1 clock pulse, at clock L, left shift, and observe this data at QD. Now, apply the next data at D input, and apply 1 clock pulse at clock L, and observe that the data on QD will shift to QC, and the new data applied will appear at QD. Repeat these steps for loading and shifting data. Let's perform parallel in, parallel out. Set mode to high, that is logic 1. Connections are made, as per circuit diagram. Apply the 4-bit data at A, B, C and D. Load data 1, 0, 1, 0 and apply clock pulse, and observe that the parallel input data is loaded to output. Repeat for different inputs, and observe the outputs. Thanks for watching the video.